Okay, let's get started. Thank you for coming. My name is Jim Nakashima. I'm a program manager on the Cloud Tools team at Microsoft. We're the team that brings you the Windows Azure tools for Microsoft Visual Studio. Now, my goal for this session is to actually help you really, when it comes down to it, understand what it means to develop Windows Azure applications using Visual Studio. In particular, I'm going to get down to the nuts and bolts and highlight the differences between the web application development that you may or may not know today. Ultimately, what I want you to walk away from this session with is the knowledge, ability, and comfort to actually just go ahead and open up Visual Studio and start doing Windows Azure development. Be it writing a new application or taking the existing application that you already have and migrating it over to Windows Azure. So to accomplish that, here's what I'm going to talk about. I'm going to start with some getting started. So what do you need on your box? And then I'm going to talk about some core Windows Azure concepts. Get us all on the same page about what exactly it is you're building, and then relate that into what you see in Visual Studio. Follow that by 3 demos, one on building a new cloud service. And I have the edit, build, debug kind of developer lifecycle, that iterative developer lifecycle that developers go through very often and frequently. Migrating an existing ASP.NET web application and deploying to Windows Azure, so actually getting your application running in the cloud. Finally, I'm going to talk a little bit about what you can expect in the future. All right, so getting started with the Windows Azure tools. What do you need to know? Well, it's an add-in for Visual Studio 2008 and Visual Studio 2010. In Visual Studio 2010, actually, if you go to File, New Project, you'll actually see a Cloud tab, and it'll have a link there where you can actually download the latest tools so that the experience is integrated. But let me switch over here to my laptop and show you. If you don't have Visual Studio 2010 and you want to get the tools, well, where do you go? So a great place to go is windowsazure.com. Not only for resources and a bunch of developer-focused pages, but to get the tools. And you can see here almost on every windowsazure.com page, we actually have a big green button called Get Tools and SDK. If I click on that, it'll take you to Download Center, where you can actually download that add-in. Now, this add-in actually installs the tools for VS 2008 if you have VS 2008 on your box, and for VS 2010 if you have VS 2010 on your box. And it installs the underlying SDK. You do have to make sure you have some prerequisites on the box. So do have a look at the instructions down here. IIS is one of the prerequisites that you need to enable, as well as there's some patches that are specific to Windows Azure development that will certainly help you out. So that's option one. But another option is to actually go to the web platform installer, which was just mentioned in the keynote earlier today by Scott Guthrie. And that's available at microsoft.com/web. And we have our Visual Studio for 2008 tools integrated into the web platform installer. And the beauty of this is what you can see is I get the Windows Azure tools installed, but I also get the SDK. It's going to configure and install IIS for me, install a patch, and in fact, even if I don't have Visual Studio, it'll install that for me as well, the free Visual Web Developer version. Which actually brings me to the final bullet on this slide, which is actually that we have a free story for developing applications that run on Windows Azure. So everything that I'm going to do today, even if you don't have Visual Studio, you'll be able to do for free. Just download Visual Web Developer Express, download our free tools, and you're good to go. Okay, so let's talk about some core Windows Azure concepts. So what is it that you're building? So I call this a cloud service anatomy. And actually, I want you to first focus on the green boxes, because the green boxes are the things that you're going to be writing. And there's 2 types of green boxes that you can write. One's called a web role, and one's called a worker role. Now, a web role is, well, it's a web application that runs on IIS. So, you know, this is a web development conference. I'm sure all of you understand what a web role is, given that it's a web application that's, you know, servicing up a web, off IIS on port 80 or 443 for HTTPS. It's exactly what you think it is. Now, the reason we call it a role and it's web role is because we have a different thing that you can also write and run on Microsoft data centers aside from just a web app running on IIS. We also have this concept of a worker role. And a worker role actually is just a way to run actually any code that you want. And so imagine this, if you will. It's you build an assembly. That assembly gets loaded up on Microsoft data centers in the cloud, and it calls an entry point. That entry point is called run. And whatever code you actually have put in run will run on Microsoft data centers. Now, there's no IIS. There's no UI or anything. But you can really run anything you want. There's full trust. We don't have admin yet. But you have all of that available to you, full trust on that VM. So, but what is a typical pattern actually for a worker? The typical pattern is actually to do long-running background processing type applications. And the pattern that we talk a lot about in terms of Windows Azure development is actually to have a web role generate some kind of message, like on a queue or something like that, to message the worker role, and the worker role goes off and does this long-running operation. So now you can also see from this diagram that I can have different kinds of web roles. I can have multiple of them. I show 2 here, but you can actually have n. And you can have multiple types of worker roles. Again, I show 2 here, but you could have n. And you can have different instances of each one of those. So you can see I have 3 boxes on the web role. And the 3 boxes actually pertain to 3 instances. And so when I say I want 3 instances of my web role 1, that means I actually get 3 VMs with dedicated hardware for each. And this is how I scale out. This is how I handle, say I want to handle 100,000 customers today, and I need 3 instances of a web role to do that. And then I want to handle 1 million later. I can just change my number of web role instances to 30, and now I have 30 VMs with dedicated hardware all servicing my application. But what does that really mean when it comes down to it from a development standpoint? Well, it means that we have a load balancer in front of those instances, and that requests are going to come to each one of those different instances. So if you have a web application today that writes to the virtual directory, the vdir, or potentially just writes to the local file system to store your data, well, that's not going to work very well if one request comes to one VM and the next request comes to a totally different VM. So you actually have to make sure that your app is stateless in this world where you're running your app in multiple VMs. So, and by stateless, I mean the data that your instances use is accessible from all of the instances in your whole cloud service, be it web and worker role instances. So we have 2 ways that you can use Windows Azure, 2 ways that you can make your data stateless. One is by using Windows Azure storage. And both these ways are actually highly scalable cloud, utility-based computing. Windows Azure storage is table blobs and queues. It's a REST interface to these storage services. And tables are just actually column row data, non-relational, fairly straightforward, but what we found is that's sufficient for a large number of apps. Blobs, as you can think of, as like a file system in the cloud. You can store data, highly scalable, pay only for what you use. And queues isn't actually storage per se, but what it does allow you to do is have messaging. So I can actually, again, going back to that model of signaling a worker, I can put a message on a queue and the worker can pick it up. The second option for data is around SQL Azure. And SQL Azure is a service as well. It's data as a service built upon SQL Server technology. So there's a TDS interface that you can use to leverage your existing SQL Server assets, skills, and to use the same kind of tools that you're used to. So those are your options for data. And that's really what we're building. Okay, with that in mind, what I'm going to do is go on to my first demo, which is building a new cloud service. All right, so I'm going to switch over to my laptop here, and I'm going to close this out. And I'm going to bring up Visual Studio. Now I'm going to go File, New Project, and create a new cloud service. And you can see under both Visual C# and Visual Basic nodes, I have a cloud node that has a single template called Windows Azure Cloud Service. I'm going to hit OK on that, and that's going to bring up a dialog asking me, well, what roles do you actually want to have in this cloud service? So that relates directly back to that anatomy diagram that I showed you. Here I'm adding roles to this cloud service. Now I could add a web role, and I have actually 3 templates for adding a web role. I can add a web role using the standard ASP.NET web application template. I can use the MVC template or WCF service template. But all 3 of these templates create a web role. It's running on IIS, and it's exposing an HTTP endpoint. I can also add a worker role. I'll do that there. And I have an option of VB, C#, and F# worker templates that I can choose from. Now, I can add multiple worker and web roles as well, totally up to whatever you want to do. But I'm going to actually, for the sake of this demo, just keep it simple and add 1 web and 1 worker role. So I've added 2 roles to this cloud service, and it's going to go ahead and create my solution for me. But you can see that 3 projects were created. So let me collapse 2 of them down just to provide some focus on the cloud service project. So what is this cloud service project that was created for me? Well, the cloud service project actually does 3 things for me. The first is it actually has Windows Azure specific configuration and tooling. So I can actually bring up like a UI. I can see some of this Windows Azure specific configuration, like the number of instances I want, the VM size, settings, which are key value settings that I can access via an API, and then change in the cloud without redeploying my app. What endpoints I want, like port 80, for example, on this web role. Some local disk space I can use for caching. Again, that data is not going to be synchronized across VMs, so be aware of that. And the ability to install certificates into the VMs that are running my roles. Okay, so I have configuration, but I also have the build output. The second thing that it provides is that the build output of a cloud service is a service package. So what's a service package? Well, a service package is everything that you need and what you give to the cloud to actually run your service. So it's going to contain both the web and worker roles that you have defined in your cloud service. And it's going to contain all the dependencies that you require as well. Now, in the cloud, you have Windows Server 08 and .NET Framework 3.5 SP1. All your other dependencies have to be in the service package. And we'll talk more about that a little later. So the build output of cloud service is a service package. And the third thing it provides is an F5 run debug experience. So, developers write code, they build it, they try it out, and they want to do that locally. They don't want that to be a hassle because you do that very frequently, right? It's a very iterative process. So to support that, we actually have a development simulation on the desktop. A cloud simulation on the desktop, which we call the development fabric and the development storage. And the development fabric is a simulation of the cloud on the way your package will run. And the development storage is a simulation of the storage services. Now, so with that, it actually takes my service package and runs it on that simulation. So those are the 3 things that it provides. And it simulates the way your package will run in the cloud. So if I hit build, and I actually browse to the folder for this cloud service, I can drill into bin debug, and I can see that I have this cloud service 20.csx file. Now, there's 2 versions of the service package. That is the service package. There's 2 versions of the service package. One that the local development simulation uses, which is just unzipped, and the one that you actually give to the cloud to run, which is actually just a zipped up version. So you can see here, if I drill into this, I have a roles folder, and you can see the various roles in here. So that gives you kind of a good idea of what the service package is. The second file is a service configuration file, which is an XML file that contains the configuration that I showed you earlier, and that can be uploaded as part of your application, or is uploaded as part of your application when you give it to the cloud, and can be updated independently of your deployment. Okay, so let's talk now. Now I've talked about the first project. Let's talk about the web role and worker role projects. So the web role project is just an ASP.NET web application project. But there are differences. This is Windows Azure development. There are some differences. So what are those differences? There are 3, in fact. The first one is under the References tab. I have 3 assembly references. One is to Microsoft.windows-azure.diagnostics. And this is a library that actually provides an API for getting information off of your machines running in the cloud. Things like trace logs, things like performance counters, and crash dumps, and things like that. So it allows you to get information off the machine that you're running. Now, it's not required, But certainly if you're building a real Windows Azure application, you're going to want to do that. The second one is a service runtime, which has various APIs that you can use that are Windows Azure specific. So one is an API I already mentioned to get at those configuration settings, those key value settings. Another is actually you can enumerate all the instances and find out what ports and IP addresses are being used for each one of those instances. So, for example, if you want to set up some communication between roles. And you can control things like, oh, I want to restart my service, the process that's hosting my service, and things like that. So it allows you to have some control over your application. So the first two actually are will only work if you're running in the development simulation. Another reason why we need that development fabric to run your service package. The third one can be used anywhere. In fact, you can use it in a WPF app. And again, is not required. The storage client library is a library that provides a .NET interface to the REST API for tables, blobs, and queues. So those are the three references that we add, and that's difference number one. Difference number two is actually directly related to the addition of the system, Microsoft.Windows.Azure.Diagnostics, which is that we actually add a trace listener to the web config file that essentially marries System.Diagnostics API to the Windows Azure diagnostics mechanism. So log messages, debug.write, trace.write, things like that will actually just work within the Windows Azure diagnostic system without any work on your behalf. Finally, difference number three is webrole.cs. This is a file that's added that you wouldn't see or get if you created just an ASP.NET web application. And there's a few things in here. One, it kickstarts and does some bootstrapping of like the diagnostic monitor, which is a process that actually runs to help you with the diagnostics. And it sets up some default behavior. Now, in this case, it says, this default behavior just says, if I have a configuration setting change, if you upload a new version of that configuration file that I showed you before, just restart the role instance. But you can control that and write some code to do whatever you want. But we provide a rational default behavior. So those are the three differences. Aside from that, you can leverage your existing ASP.NET web development skills and go ahead and start developing. Now, talking about the worker role, just to really illustrate what I meant by, you can load an assembly and your assembly will be loaded and an entry point will be called. That method is called run, and you can write whatever code you want here. And that's really about it. Okay, so let's actually take this web role and modify the ASPX file and say hello from Windows, or hello MIX10. How about that? All right, I hit F5. A few things are happening for me. Again, that service package is being built by the Cloud Service Project. The development fabric and storage services are starting up, and we're communicating that to those to actually run your application. So you can see here I have a development fabric UI that I can bring up. Actually, let me just hide IE for a minute. And it shows that I have both a web role and a worker role, and I have one instance of each running. And that's part of the simulation. I also can bring up development storage, and you can see on local endpoints, I have blob, table, and queue services running. So the other benefit of this is I can actually develop without having an internet connection. And I can also develop without incurring any costs. So those are the other benefits of having this local simulation. Now I'm going to bring up the web app again, and you can see there that it's running just as expected, standard ASP.NET. Okay, so let's take that one step further, because I want to show you some debugging. Because in this world now, I've got different roles, right? And I've got a different number of instances. So how does that relate to the debugging experience inside Visual Studio, along with this dev fabric and all this kind of stuff? So how does that all work? So to do that, what I'm going to do is, first of all, I'm going to change the instance count of the web role to 2. And then I'm going to open up this default.aspx again and drop a button on it. So what I'm actually going to write some code for is to do that communication that I talked a little bit about. Being able to communicate between a web and a worker role through the use of a queue. That way I can show you the debugging experience across multiple roles. Okay, so just double click that button. And I have an event handler, which I'm actually going to set up a queue. All right, so double click that. And actually, before I talk about the code, I'm going to add some namespaces to actually get rid of the squigglies. And, oops, I'm going to add that. And copy those. I need one for the service runtime and one for the storage client. Okay, and that gets rid of the squigglies. I'm going to give myself a little more space here. So the first line of code actually gets a configuration setting from that configuration file that I talked about, and it's called diagnostic connection string. So let's look at that real quick. Under web role settings, I have this diagnostic connection string already set up. That actually was a part of the template, and just for ease, I reused that same connection string. And you can see that it's set to development storage today. If I want to change it to use the real cloud storage, I'd actually just change these credentials to actually input an account name and key that corresponds to the credentials I get off the portal when I create a a storage account. So that's the connection string. So it gets that value back, and it passes it to this cloud storage account.parse method, which returns an object that says, okay, well, I know about these credentials. I know how to talk to that particular storage account. And we ask it for a queue object, which we can actually use to talk to queues. And that's what I get back in this next line. From there, I say, give me a queue called MIX10, and create it if it doesn't exist. Okay, so from there, all I want to do is add a message to that queue saying, hello from the web role. So I do that, and that puts as a message on the queue, and I'm going to go ahead and write some code for the worker role to actually find, look for that message. So I need that same code to set up the queue. And I need a couple more usings. I need the standard one, and I need storage client. And that gets rid of my squigglies. And in this case, I'm going to actually watch for a message, because the worker is going to be watching for a message. So what I have here is I'm polling for a message by calling getMessage. And when there is actually a message, I'm going to just write that message out to the logs. And let me set a breakpoint on that and go back to the web role and set a breakpoint on when I'm adding a message. So hit F5. So let's see what happens here. So again, that service package is being built. It's communicating with Development Fabric. And let me bring up that Development Fabric UI again, because one of the things I want to show is actually that there's multiple instances this time. Again, there's the web and the worker role. But you can see I now have 2 instances of that web role running. And the thing about that is we have a software load balancer that we install as part of this simulation, so that you can actually simulate running multiple instances and having them hit different instances each time right on your desktop. Okay, so I click the button and I hit a breakpoint. Great. Exactly what I expected, exactly what you would want, right? And in fact, you get all the debugging experience that Visual Studio 2010 provides for you. But that's actually putting this message on the queue. So let me hit F5 again and see if the worker picks it up. And yes, it does, and it hits my breakpoint. Now, what really happened there is I'm actually debugging across roles, and in fact, across instances too. And that just works as you would expect. So what's really happening, though? How does that work? And conceptually, how are these roles running? Well, as it turns out, I can answer that question by popping open this process list of the processes that we're actually currently debugging. And you can see here that I have 2 instances of a WA web host process running and that we're debugging. And that directly corresponds to 2 instances of my web role. And I have 1 instance of WA worker host, which corresponds to my worker role. So these processes is how your actual roles run. And in fact, in the cloud, they run in these exact same processes. Now, the difference here is on the desktop. I'm not spinning up a VM for each one of these processes, giving you dedicated hardware, of course, or even an exact environment. But we do simulate it by having these different processes and attaching to each one. So there is actually a quick tip here. Hopefully, will save you some time down the road. I'm using a 64-bit OS. So these processes are actually 64-bit. Now, in the cloud, these processes are also 64-bit. But we support development on 32-bit machines. Super important. In fact, our data shows that primarily you folks are developing on 32-bit machines more so than 64-bit machines. We've seen that data change over time, but certainly even today, there are more people using 32-bit. So what does that mean in terms of these processes? Well, certainly they're not 64-bit processes on a 32-bit machine. That's just not possible. So they're actually 32-bit processes, as you would expect, which actually means that if you're using, say, a 32-bit DLL and everything's working fine on your local simulation, when you actually run in the cloud and you run in a 64-bit process, that may no longer work. So just having that information could probably save you a lot of time if you're using DLLs and various things like that. So just be aware that 64-bit process is always in the cloud. Now, we also attach to Internet Explorer to provide client-side debugging. And there's one more thing around debugging that I want to show you, which is if I open Solution Explorer again and go to the web role and click Properties, Web tab, down at the bottom, there's debugger options. Now, we actually read these when we're running a cloud service. So if you're writing native code and you want to debug native, you can click that checkbox. Or if you're using Silverlight, you can click that checkbox as well. So it's the same way that you're used to today. The thing is, it might not have been obvious that those values are actually respected when you're running in a cloud service. Okay, so that's the initial experience, creating a new project, adding roles to it, debugging, running on this development simulation. Okay, so now let's talk about migrating an existing ASP.NET Web application to run on Windows Azure. So back here, what I'm going to do is open up a second instance of Visual Studio. And yes, I do have to run admin rights, admin privilege. It's just our development fabric today requires admin, and to debug those processes that are running admin, we also need to run admin. So that's the reason behind that. We are looking at ways to remove that requirement moving forward. So I'm going to open up an existing project, and it's called Nerd Dinner. Now, Nerd Dinner, for those that you know it or don't know it, it's actually a sample that was written for Professional MVC 1.0. Which is actually, incidentally, the same book that they listed on eBay in yesterday's keynote. So if you want a signed copy by Scott Guthrie, well, you can certainly go buy it on eBay, apparently. All right, so Nerd Dinner, what is this? What does this look like, and what does this do? So I'm going to hit F5. You can see that the ASP.NET development server is running. So this, no smoke and mirrors. This is really just an ASP.NET MVC application. And you can see that this is what the application looks like. And there's two things that it essentially allows you to do. It allows you to host dinners. So I can log in as a particular account and host various dinners and schedule those dinners. And then I can also find dinners and say, view upcoming dinners, and it gives me a list. And it uses two types of data, in fact. One type of data for the account and registration information is through the ASP.NET providers. So it uses both the membership and profile providers. And the second type of data that it uses is the dinner data itself. And in both these cases, it's actually using SQL Express. So as I'm running this on my machine right here, it's actually using SQL Express. Now, if you remember back to the anatomy of a cloud service, this is really a one-box solution. I can't actually just push this up to the cloud the way it is because I can't use SQL Server or SQL Express directly on the machine that I'm running in the cloud. I need something that's scalable. Okay, so what are my options? Well, I could use Windows Azure storage, as I mentioned before. And I could actually use tables for this. And if you want to find a sample of that, you can actually search the web. There are samples out on the web where people have done that. Now, for the sake of this demo and for the sake of showing SQL Azure and the power and simplicity of actually migrating to SQL Azure, I'm going to use SQL Azure both for the providers as well as the dinner data. So there are three things that I need to do to successfully migrate this application from being a one-box, IIS-hosted ASP.NET Web application to being a scalable cloud service that actually could service any number of customers. So the first thing I need to do is I need to make this Nerd Dinner web application a web role inside a cloud service. The second thing I need to do is migrate the dinner data to actually use SQL Azure. And the third thing I need to do is migrate the ASP.NET provider usage to actually use SQL Azure as well. Okay, so let's get started. Let's do that. So the first thing I'm going to do is right-click on the solution, add new project, and I'm going to choose this Windows Azure Cloud Service again. This time I'm not going to add any roles because I have the role already in the solution that I want. Now that's not sufficient. I haven't actually made the hookup. So I go to Roles node and select Add, Web Role Project, and Solution. And this gives me a list of all of the web application projects in this solution. In this case, I only have one. So I'm going to select that and say, yes, make that a web role. Great, easy as that. That's set up. I actually have, oops, that's not what I meant to open. I actually have configuration for that web role, Windows Azure specific configuration for that web role as well. Step 1 done. But if I hit F5 now, I'm still using SQL Express. So let's now go to SQL Azure. I'm going to go to the SQL Azure portal. And I'm going to choose my account. And I'm going to create 2 databases. The first database that I'm going to create is called ASP.NET-DB, which is going to be used for my ASP.NET providers. The second database I'm going to create is called Nerd Dinner, and that is going to be used for my dinner data. The other thing to point out here, which is really handy, if I click on one of these databases, I can click on connection strings, and that will actually give me the connection string, which I'm going to use later. So just kind of a quick tip around that. Okay, back to Visual Studio. And to migrate my database now, I'm actually going to use SQL Server Management Studio, R2. And this R2 CTP is available for download. And what it actually provides is the ability to connect directly to a SQL Azure database. But first, I'm actually going to connect to SQL Express. And one of the things I've done ahead of time is actually just attach that Nerd Dinner database to SQL Express so that I can save that step and just go right to tasks and generate scripts. Now, when I generate scripts, this allows me the capability of migrating a schema or migrating a schema and data. In this case, we'll just migrate the schema. So I go through here and I select the whole database, but I need to click Advanced because I want to script this specifically for SQL Azure. So there's an option here saying Script for Database Engine Type, SQL Azure. Because there are some differences with SQL Azure by nature of it being a service versus a hosted SQL server. So I hit OK. I'm just going to open that to a query window, and I'm going to let that run. So that's now creating a script to migrate my Nerd Dinner database to SQL Azure. So my next step will actually be to run that script against the Nerd Dinner database that I made in the SQL Azure portal. Okay, so that's finished. It opened up here. I'm going to disconnect and connect up to SQL Azure this time. Whoops. And you can see that I have a database.windows.net URL there. And I'm going to select Nerd Dinner. So I connect up, run the script, and that actually sets up my database in the cloud. Okay, now the second thing I need to do, the second type of data I have, is the ASP.NET providers, right? Now for those of you who are using ASP.NET providers today, membership, roles, profile, session, et cetera, and you use it against SQL Express, chances are you've never worried about setting up a database. You hit F5 and everything works. For those of you that use it against SQL Server, you may be familiar with a tool called ASP.NET Reg SQL.exe that will actually allow you to set up the provider schemas on any SQL server. In the case of SQL Azure, we currently don't support that tool today, but we have actually released scripts specific to using providers on SQL Azure. So I have those scripts downloaded already. And I'm going to run them. And this time, I'm going to disconnect and reconnect to, yeah.
So you have the scripts are available, and you just go download them, and then you just basically create your
Exactly. And I'll have links to this stuff afterwards. So the question was, so I just downloaded these scripts, and now I'm going to use them against my SQL Azure database. And that is correct. That's exactly what I did. They're available for download from Microsoft.
What if you have existing provider data?
Well, so the question is, what if you have existing provider data? You can use the common bulk copy and I forget the other name, the standard protocols for copying data, and that is supported in SQL Azure. Okay, so I connect up to ASP.NET DB, and this time I run that script. And since I'm using membership, I'm going to open and run that script. And since I'm using profile, I'm going to open and run that script. And so that's all I need to actually set up my SQL Azure database for the ASP.NET providers that I'm actually going to use. So let's just double check that everything completed. Great, and it did. So I'm going to close SQL Server Management Studio now, and I'm going to go back to Visual Studio and open up my connection strings. And you can see here in the connection strings, they're actually set up to SQL Express. So I'm going to delete those, and I have some already on the toolbox, which are pointing to my database, which I just set up. And you can see there that it's using the same database. All right. Okay. So now I've migrated my database for both the dinner data, the profile data, the ASP.NET provider data, and I've made this a cloud service. I hit F5 now. I'm still running on Development Fabric, but I'm actually going to be using SQL Azure data in the cloud. Okay, so that runs. Internet Explorer comes up, and there's my application running on Windows Azure. Now, just to verify that that's all working as expected, let me just register an account to show the use of the providers. Yeah, this is still running on Development Fabric. I'm going to deploy in the next step. And you can see that that worked correctly. I am using cloud data. I am using SQL Azure data in the cloud, though. Now I can host a dinner and to verify that the dinner data worked correctly. And I will do this. And let's see. And hit save. And there you have it. That data was stored to the database, and so both my databases were set up correctly. Okay, so now I want to talk about the next step to that, which is actually deploying to Windows Azure, and talk a bit about that experience. So again, going back to demo mode here, just staying in demo mode. It's actually really easy to create slides like this. Love it. So before I actually deploy, though, there's a couple tips that I want to talk about. The first tip is around using Windows Azure Storage. So I'm actually going to go back to that first app that was using Q Storage. And I recommend that you always do this for all of your applications that use Windows Azure Storage. And that is to actually run first locally with your app running on the Dev Fabric, with your data actually pointing to cloud data. And so what I mean by that is to actually change your connection strings to use cloud data, but still run on this Dev Fabric. So, and to actually be very rigorous about this and make sure that you don't make any mistakes, I'm going to go to this Development tab on the Cloud Service project and change Start Development Storage Services to false. Then I'm going to go to this our tray icon for our development simulation, and I'm going to shut down Development Storage Service. This guarantees that if I'm using any local development storage strings, I'm going to catch it before I actually deploy to the cloud. This just weeds out one thing that can go wrong. And so I highly recommend that you do that. All right, so now I open up my configuration here to the settings. You can see diagnostic connection string. You can see that it's currently set to development storage. Change that to a real account, hit F5, make sure everything runs as expected. Highly recommend doing this. It's very easy. I've done this for like a year and a half. I've deployed apps for like a year and a half, and what I've found is inevitably every once in a while I forget to change a connection string, and it's just so much harder to figure it out once you're deployed than actually on the local development fabric. Now, actually kind of a corollary to that is you can use this in a slightly different way, which potentially could be useful for you, which is if you already have an app that's running in the cloud, and you have, I don't know, say 3 or 5 instances of your roles running in the cloud, you can actually hook up to the same cloud storage that those roles are using, hit F5, and run your app locally and essentially add another role to your existing running service, and then debug that service using the same, debug locally using the rich local debugging, but pointing to the same data. So potentially if you have a situation where data, specific data is causing problems in your application, you can actually still debug that locally. So now it's not going to work for all situations, but certainly a useful little tip to have in your pocket in the event that you think that might be a situation you could debug locally. All right, so I'm going to close this one down now, and I'm actually going to go ahead and deploy Nerd Dinner. Oh, actually, I'm going to talk about the second tip that I wanted to talk about, which is going back to the service package that I talked about earlier, which is that this service package is everything and all your dependencies that you need to run in the cloud. And if you recall, in the cloud we have Windows Server 08 and .NET Framework 3.5 SP1. So how do I make sure that I'm getting everything that I need in the cloud? So I'm going to right-click on the cloud service node and hit Publish. And that's going to do a couple things. It's going to bring up the portal, but it's also going to bring up Windows Explorer to the service package that I created here. So what I want to do now is actually drill into this thing and see if it has everything that I need. Now, by default, I can't do that. It's encrypted, and there's no way I'm going to be able to unpackage it. But because I've set up an environment variable ahead of time called cspack force no encrypt, right there, and I set that to true, I'm able to actually drill into that service package. Now, this doesn't affect my ability to deploy the app at all. I can still deploy the service package. But what I can do now is change this to a zip file and actually just drill into it. And I can see here, follow the white rabbit. I have a size here of 1.7 meg, and it's called Nerd Dinner, so that's certainly my Nerd Dinner role. I bring that out of the package, and I change that to a zip file. And I can drill into that. I can see here that there's my Nerd Dinner application. So I go into bin, and I see my Nerd Dinner DLL, and I think, great, that's great. But, and I did this for illustrative purposes, and I wouldn't have run into this problem if I created a new MVC app as a web role. But in this particular case, because I'm migrating my app, I'm using MVC, but MVC is not a part of .NET Framework 3.5 SP1, right? So I need to make sure whatever dependencies I have on MVC are actually included in this service package, which you can see today it is not. So let me go back to Visual Studio here. I'm going to open up the references folder, and you can see that I have system.web.mvc. I'm going to click Properties. I'm going to change copy local to true. And that's actually going to give me what I need. Now when I package this service, publish the service package, that's actually good to go, and I'm ready to deploy. So that's the second tip, really just to make sure that you have all of the dependencies that you require in order to successfully run in the cloud. Again, it's much easier to take a look at that before you deploy than afterwards. Although we're doing a lot of work, I should say we're doing a lot of work over the course of this year to make it much easier to debug and diagnose issues that are running in the cloud. Certainly our focus this year. All right, so to deploy, I can go here to the development portal. I can click on my account, click on a hosted service, which I set up, and start the deployment process. Now, I'll go back to that publish folder, take that path, copy that path, and when I click deploy, I need to give the development portal my package. So I'm going to browse to that service package. I'm going to browse to that service configuration, and I'm just going to give that a label. And it could be any label that you want. It can't conflict, though. And I'm going to hit deploy. And that's actually going to now deploy my app. It's going to upload it to the cloud. It's going to unpackage it. It's going to start running my roles. Actually, I have to click one button to actually run the roles, but I'll show you that in a minute. Now, while that's going on, I'm actually going to open up a Windows PowerShell and show you a second way that I can actually deploy to the cloud, which is through an automated means. Now, there's two reasons I'm actually showing you this. One is actually to show you that we have PowerShell commandlets that allow you to automate deployment. And in fact, we have a PowerShell commandlet that allows you to delete deployments as well, which actually for the developer audience is very handy. Because you might be deploying to the cloud as part of your development activities. At the end of the day, you're about ready to go home. You should just run a script to actually kill delete all of those deployments. And the reason why is if you're using it for development, you don't want them running overnight. You get paid per the hour, right? So handy little script also to use. The second reason I'm showing you this is actually to show you that we have a service management API that you can write code against to actually manage your application. And you can do all kinds of things like deploy and change configuration, change instances, and all that kind of thing. All right, so I have this script. It's called deploy.ps1, and I'm just going to pass in that same folder. And that's actually going to do the deployment. That's going to automate the deployment. So let's go back here to the portal. And I'm going to open that up. I'm deploying one to staging and one to production. This is taking a little longer than I expected, but that's all right. In any minute now, I'm going to see the staging slot here on the right switch over. So let me hit refresh. And that should show that I'm actually now deploying. The script is running. It's seeing it's in progress. And this will come up any second and show you exactly what I was talking about. Oh, come on. All right. You know what? Let me come back to this. I'm going to actually continue on, and then we'll come back to the portal and just see that everything got running as we expected. All right. So some Windows tools, features, and it's actually been hard for me not to kind of contain myself a little bit as we talked about things, because I wanted to talk about some of the things that are coming down the road. So this is a tools-focused features. The platform has their own set of features, which they're doing things that we've announced already, things like remote desktop to VMs, admin access, VM configuration, and things like that. All very exciting things, all very important things. This is more just on the tools side. What are we working on over the course of the next year or so? The first thing you'll notice is that I've been using .NET 3.5 the whole time, right? So the obvious question would be, well, what about .NET 4 support? And as it turns out, what we're doing is, from 90 days of .NET 4 RTM, we're going to have .NET 4 support in the cloud. So that's coming, and we're really excited on it. The product teams are working on it as we speak. Second thing, developer support for deploy. And now you saw when I went to actually deploy this application, I actually left Visual Studio. I used the developer portal, or I used some automated scripts. Well, we're certainly going to have an integrated experience inside Visual Studio. We needed that service management API first, and now we have it, so now we're building a developer-focused tool. Now, and I say developer-focused because this is not the place, Visual Studio, when we have this integration with deployment, this isn't the place that you're going to go as an ops guy and monitor your production app and do all those kind of things. This is really, as part of the developer lifecycle, you are going to deploy, test, and edit, build, debug, deploy, test, and do that type of activities. And we really want to support that scenario for you inside Visual Studio. Debugging and diagnostics tools, if you use this today, I mentioned a couple times, try to weed out as much as you can on your desktop before you deploy. We're going to make this whole experience easier to figure out what's happening in the cloud moving forward. And some of the things I mentioned that's happening on the platform, things like being able to TS into or remote desktop into a machine will certainly help. And developer support for storage and data, being able to actually see what's happening when you run code, seeing how you're modifying data and what's happening in your storage account and things like that. Now, as we were sprinting towards our V1, our commercial launch in February of this year, we were really focused in the Visual Studio side in terms of providing a familiar experience for Visual Studio users. And that was really what we were working on a lot. Now you can see as we're moving forward, we're really shifting gears a little bit. We're realizing, okay, well, here are the things that are difficult, and here are some tools that we can do and write to make things better and make you more productive, which is great. It's a really exciting time. But while that's happening, the platform is also changing. There's a lot of cool things happening on that side, and we're a part of that in the tools. And so we sim-ship with the SDK, and we sim-ship with the announcement of features. And really, the other main thing that we're working on this year is to support end-to-end the developer experiences for all the new things that are coming in Windows Azure as well. Okay, so I can actually flip back here and show you that both those apps deployed. You can see on the right, this one's initializing. I actually have to hit run in production here to actually run that application. But everything deployed as expected. You know, network connections at conferences, we really tax infrastructure like nothing else. Okay, so you saw that now confirmed that actually deployed, that app was initializing, and in a little bit it'll actually be available on the internet, hittable from any internet-connected device. A quick note about SQL Server, SQL Azure and Visual Studio. If you use SQL Server tools in Visual Studio today, things like Server Explorer, for example, in Visual Studio 2008 that doesn't work. The key message here off this slide is Visual Studio 2010 is a great developer platform for SQL Azure, and we've done a lot of work to enable the tools inside Visual Studio to work with SQL Azure. Okay, so quick summary. What did I talk about? Well, I talked about what do you need on your box. I talked about some core Windows Azure concepts and what those actually relate to in terms of what you see inside Visual Studio. And demoed the new project experience and migrating an existing application experience, as well as deploying to Windows Azure. And talked a little bit about what you can expect coming down in the future. So as I wind down this talk now, I want to leave you with a couple resources. One of the things that you're going to want to know are like a link to the providers. Where do I get that? And where do I get the PowerShell scripts? And where do I get a summary of some of the things that I talked about in this talk? Well, go to blogs.mstn.com/jnac. In about half an hour, I have a post that's ready to go and will auto-post. And it'll contain all that information. If you have any additional questions or comments or feedback, love getting feedback. Twitter and email, jnakashima and jnac@microsoft.com. Feel free to contact me anytime. And finally, windowsazure.com is a great place to actually just start. There's a link to the forums. We have a very vibrant forum community. And one of the things that's actually really great about that is there's a lot of people from the community now really starting to dive in and answer other people's questions, and it's taking a life of its own, which is really great. Okay, so please fill out a feedback session evaluation. Really makes a difference to us, and we actually pay a lot of attention to that information. And before I open it up for questions, I just want to say thank you for attending, and I really hope that this has been useful for you. Thank you. So questions, please go to the microphones, actually, if you will. No? No, okay. You can yell it, and I'll repeat it.
I was just going to ask, for the worker role, can you have an assembly that you created and deployed to a worker role that communicates over sockets?
Over sockets. So the endpoints that you can have on a worker include TCP and HTTP endpoints. And you can have both externally facing load balanced endpoints, and you can have internal ones as well. So I believe the answer is yes, but I'm not entirely sure about the use of sockets. Actually, you would know that answer.
If it's TCP, the answer is yes.
Yeah, okay.
So I could have an assembly opens up a socket directly to some consumer outside it.
Outbound, you're unblocked. You can do anything you want. Inbound, you need to come in through the load balancer, unless you're communicating within your deployment, in which case you declare the ports beforehand, and you have a direct point-to-point connection within your roles.
So outbound I can, no problem. Inbound I have to go through the load balancer, which means I'm in HTTP land.
Yes, or you're in TCP land.
Yeah.
You can load balance a TCP connection.
Oh, so you guys support incoming TCP sockets?
Yes.
Okay.
Actually, I could show you that really quickly just by opening the configuration endpoints. Oh, actually, let me add a worker role. Endpoints, you can see you can add any number of endpoints. You have input, which are on the load balancer, and internal, which are only available to the roles within your service. And then you have HTTP, HTTPS, and TCP protocols. Any other questions? Oh, okay, yeah.
Service broker, since SQL Azure is SQL Server, is the service broker functionality of SQL Server available through some sort of mechanism?
Server broker. Actually, service broker. Actually, I'm not familiar. Sorry, this is embarrassing. I gotta hand it off to this guy wearing a polo shirt. This is Ryan Dunn. He's actually a member of our DPE team, and he works on Windows Azure.
A lot of these things.
Yeah.
So I'm pretty sure the answer is no. If the service broker is not available, I think that's what we use to coordinate multiple databases and transactions. Is that right? The answer is no, I believe. However, I would really recommend that you go to David Robinson's talk. I think it's at noon tomorrow, and he's going to be talking about SQL Azure all up. And it'd be a great place to ask him that. If it's not available today, the answer could be it's coming. I don't know. And David Robinson would be the right guy to talk to.
Yeah. Any other questions? All right. Well, thank you very much. Oh, yeah.
The WCF services in Windows Azure, because I remember like a preview, maybe it was last year, it was REST only. Is that still the case?
No.
So your standard WCF service that we write today, we can deploy to the cloud?
Yes, absolutely. All the bindings should work fine.
Okay.
Yep.
Yeah, there is actually one thing I will point out is there is a site called code.msdn.microsoft.com/WCF Azure. And there's some tips there that actually will be really useful for you. In particular, because of the load balancer, proxy generation doesn't work as expected. But you can definitely read about it. So there's a patch and a little bit of a fix. But you can read about it there and figure out what are the things that are slightly different. Yeah. Yeah.
Is there performance counter support?
Yeah. So part of the diagnostic system, you can get at the performance counters off the machine.
Can you add custom performance?
No, you cannot. Not yet.
That's a point in time limitation.
Yeah.
So to add a custom performance counter requires admin access. When and if admin access comes, or more like when admin
When admin access
that'll be
comes. Yeah.
unblocked. But currently, you just have the performance counters that are installed at the machine.
Yeah. All right. Thank you.